Hi guys, welcome back to Comp Show. Today the topic is linear search. I'll be explaining you what linear search is, the explanation of the concept why we write the code in kind of you can say it pseudo code kind of thing, and then we will look into the code. So this is the first section. Why do we use linear search? Linear search is again one of the two most used searching algorithms. The first being binary search for what we discussed in the previous video. So coming back to the topic, linear search has few advantages over binary search. Let's make it very clear. First advantage being in binary search, the list has to be sorted. If the list is not sorted, it cannot tell that, okay, we can cut this part, okay, we can cut this part. That can only happen when the array is sorted. If the array is not sorted, binary search won't work because it cannot assume that all elements of the part we are cutting are sorted. This problem is tackled using linear search. So linear search operates in unsorted array. It has its own disadvantages as well, because when you are using linear search, it will go through every element in the array or the list. If the, let's say for example, there are few things that can actually optimize it and make it better. If we are finding an element, let's say x, and the first element of that particular array is only x, then though it doesn't have to go through every element, right? It has found its the target value and boom, it will return. That's the best case scenario, but most of the times, like, it doesn't happen. So if there are 5 elements, it will have to go through 5 iterations, and then depends on which index it found the element or not found the element, that as well. But when the amount is much higher, like let's say a crore of reservations in Indian Railways, and we have to sort out which one is mine, right? And it's an unsorted, then it becomes very tedious. That's when we use something like a binary search. So both algorithms has their own flaws and cons, but this is the thing, linear search, its time complexity is on, as I said, because it's going through every iteration. So the amount of items in the array will determine how good that algorithm is. So yeah, this is enough for it. Now we will look in the explanation of how we write the code and why that code works. Okay, so we'll be looking right now at a searching algorithm called as linear search. It's a very basic kind of algorithm. As we have seen before in binary search, we have to do, like, we have to take a low, a high, a mid. In linear search, it's much more simpler, but because it's so simple, it takes a lot of computation power because it goes through every element in the list. If you're taking a small list which is of 5 6 element, yeah, then that's great. But when we are talking about a list which has more than a lakh or crores of number, then it becomes much harder. So that's why linear search is one of those kind of those searching algorithms which will take a lot of time to complete. Basically, the time would be the amount of numbers. But coming forward, we will check what it really happens here. Let's take a particular list here. Let's take any amount of numbers. One advantage of linear search is that over binary search is that binary search, the elements have to be sorted. If they're not sorted, it won't work. But for linear search, that's not compulsory. It can be unsorted as well. Because of fact it's going through everything, it will find the element. It doesn't need to be sorted. So let's take 8, 11, 2, 5, 19, 21, 3. Okay, so what it will do is that it will take a pointer as I would be a pointer. Let's change the color for better understanding. I would be the pointer. What it will do is that until and unless the whole length of the array is not complete, it will keep iterating from here, from here, from here, from here, from here, from here till the end. Let's take the desired element that we want to be 21, the second last element. What happens here is that if it finds 21, well and good. The moment at which it finds the value, the algorithm will break. and we will get the result. If we don't find the value, it will keep iterating, and at the end, if it doesn't found, the code will finish, and the result which we will get would be that the elements are not found. So right now, because of fact this code is so small, I can explain you the meaning of the code as well, and later we will look in computer as well, what we get as the values, how the code looks, how to program it. First thing first, we will take a variable which would be found. We will set it to false because right now we have not found our element yet. We have just seen the list, and this is the first point the iteration has happened. The best case scenario for linear search would be the desired element is the first element of the array. Then it will just check and it will just print, yeah, if we have found the element. But in most case scenarios, that's not the case. So first things first, we will take found as false. Then we will write a for loop, which would be like for I in range length of array. This code basically means that, as I said, I will start from the first index and will iterate through the whole length of the array. Now, if list I equal x, this basically means that after one point of the iteration, the index value is equivalent to the desired value that we wanted. If this happens, first things first, we will print that particular index, print the index. We will do this found will be changed to true, which was initially false, because now we have found the value, we don't really need it to be false. And then we will break out of this particular loop. Why are we breaking out of this loop? Because once we have found the element, we don't really need to check the next element, right? It will be waste of computation. That's why we'll just straight away break. But this is an if case. This is a very, you have to see these things. There is a if here. If this happens, then only break. But what if this doesn't happen? So for that, we have another line of code which should be going like this below. But if found is false, this basically means after going through this part of the loop again and again and again through the whole length of array, if the value of found is yet to be false, then we'll straight away return element not present, because it makes sense, right? If the element was present, it would have been seen in this particular loop above, but since it's not present, we will straight away print element not present. Now we'll go forward and check how to code this. Thank you. Okay, so coming to this section, code section, we will be writing the code for linear search and we will be seeing how it works. Let's go. First, we will be defining the function, defining linear search. In here, we will give two parameters, which will be the list of the array and the element that we need to find, which we will be putting as x. First, we will iterate through the whole array using I. For I in range, and the range would be length of the whole array. After this, we will use a if loop. If x equal arr I. This means basically if while iterating, if at any point the value of x is equal to the I, then we will return that the element has been found. Or if after going through the whole list, once in a while, if the element is there, it will find it, right? But there might be a case where it might not find. For that, we will writing this code. So basically, if it's not there, it will come out of the loop, and once it comes out of the loop, it will return the element is not present in the array. Okay, so we'll run the code. Oh, it's connecting to Python, it might take a bit of time. Meanwhile, let me sip a bit of water. Yeah, it is working. So while now we will let's name a list, not array this time. List equal to, okay, can't name it because this is a variable name. This is a good thing you learned. You have naming conventions, and right now I went against the naming convention, so I'll keep it array only array. The list, because we can give unsorted one, we can just write random numbers here. 43, 65, 88, 32, 4, 22. Okay, decent amount of numbers. Let's check if this function is working or not. In a search, the name of the array is array, and we want to find which element. Let's find 33 first. The element has been found. Great. Let's try one more. Let's find 4. The element has again been found, but now let's try some other number. 18. Element is not present in the array. So yeah, this is the code. This is the code explanation we did. Thank you. Yeah, so as we saw, after the explanation and all code, you understand what linear search is. Linear search is a good algorithm, but it's not very good if the amount of data is a lot, which in all today day and age work would be more only, so which will make linear search a bit of not that good of a data. But if the amount is less, then linear search I would say is much better than binary sort, because for binary sort we need a sorted array, and I don't think data can always be sorted. Yes, you can, but in real life scenarios as well we can use it. So yeah, this was linear search code and explanation. Thank you for joining in, and yeah, take care, have a good day.